So for number 22, I start from the left-hand side, and I get cosine squared x plus 2 cosine x cosine y plus cosine squared y plus sine squared x minus 2 sine x sine y plus sine squared y, correct? Yes? Okay, how much is cosine squared x plus sine squared x?
Oh, that's
1. How much is sine squared y plus cosine squared y? 1. So 1 plus 1 is 2. Correct? Plus, I will factor out 2 from these two, and in parentheses I write cosine x cosine y minus sine x sine y.
that's just the cosine addition.
Exactly, and I'm done.
Okay, I just negative on side,
So this is 2 plus 2 cosine x plus y, and this equals the right-hand side. Agreed? Okay. Now we are working on number 37. So 2 cosine squared x minus 7 cosine x plus 3 equals 0. The test is tomorrow at 4:30 in this room, correct? If you want to come in earlier, please do so. Can we start on this one or not yet?
yeah.
So what would be the first step here?
I pulled out a cosine.
Not possible. This is a quadratic equation in cosine. I can't do that. This is like saying cosine x, let cosine x be y. So this is 2y squared minus 7y plus 3 equals 0. No, if it's something squared, you can't separate the terms like that, right? So I have to factor and get and solve for cosine first, correct? We agree, we disagree, we may agree. So we agree. Thank you.
Then it's back.
Yes, once you solve for y or for your cosine x, you don't have to change the variable. You can keep cosine. I just wanted to show you that it's quadratic in cosine and we have to solve for cosine first. So you have to factor this.
Then when you find that, you plug that back in to see which one would work, or do you not have to plug it
You mean to check the answers?
Yeah.
Cosine is not a ratio.
in? Okay.
Tangent is a ratio. Secant is a ratio. Cosecant is a ratio. Cotangent is a ratio. So whatever you get here, it should work.
Okay.
Unless you come up with cosine equals -5.
Tan equals-
Right. The minimum is -1, the maximum is 1. So how do we factor this?
So I use quadratic formula.
That's fine. That's fine too. Okay, perfect. So then y equals 2 options.
So I got 3.
So in other words, this is cosine x equals 3. Oops. And cosine x equals 1/2. So what was our conclusion about cosine x equals 3? Right. Not possible. So the only option is then cosine x equals 1/2. And we know we have to find infinitely many solutions, but 2 different ones. Where will I find those?
So at 1/2.
First of all, which quadrants?
First, third.
Exactly.
Sorry, first. Fourth.
Right. Cosine is measured on the x-axis. So it's the first and the fourth. Perfect. And now I have to think in terms of that little chart. Cosine of which angle is 1/2? And it's not the top one and it's not the middle one. Because the top one has 1/2 in front of sine, not in front of cosine. Pi over 3. Yes. So then there is a pi over 3 here. And I have to draw a vertical line. It crosses the graph in another point. I connect the center to that particular point, and this is the second angle. And we should always give the answers in positive angles when we solve trig equations. I recommend that. Exactly. Pi over 3 plus 2 pi k. And the other one is, of course, I have to write 0 plus or minus 1 plus or minus 2 dot dot dot. So what is the other one?
Pi power 3.
Yes, because from 2 pi, you subtract pi over 3. From 2 pi, you went back pi over 3, which is indeed 5 pi over 3. Very good.
So you did 2 pi minus pi over 3?
Yes, because this is pi over 3, and this stops pi over 3 short of 2 pi. Okay, number 40, please. Sine x equals cosine twice x. Number 40. Sine x equals cosine twice x. So can anyone give us the idea here?
So I turn cosine of 2x into 1 minus 2 sine squared x.
Excellent. So because you want the same trig function, very good. And now?
You would all to the left side.
Exactly, because it's quadratic in sign. Exactly. So this is 2 sine squared x plus sine x minus 1 equals 0. Of course.
So what's the formula for cosine 2x?
Yes, there are three formulas for cosine twice x. Cosine squared minus sine squared, 2 cosine squared minus 1, and 1 minus 2 sine squared. Let me write them here. So cosine twice x equals cosine squared x minus sine squared x. If you change cosine into sine, then you have 1 minus 2 sine squared x. If you change sine into cosine, you have 2 cosine squared x minus 1. All these mean the same thing.
Okay, I used the first one. That's what I was.
If you use the first one, then you still have one more step because you have to get rid of cosine. You can't have sine and cosine squared and sine squared in the same trig equation. If you choose the second one, then you're in business because you only have sine. Do we have the factor form? Or the quadratic formula, whatever. But I need 2 values for sine.
I think I got -1 plus 2 times square root of 3 over 4. That's my quadratic formula.
Oh, this is factorable.
Oh, I don't know how to do it.
That's okay. So let me show you. So if we have 2y squared plus y minus 1 equals 0, since the leading coefficient is not 1, we will have to incorporate it in the product. So I'm looking for 2 numbers whose product is -2 and whose sum is +1. Since the product is negative, one has to be positive and one has to be negative. So remember, this is the product if the leading coefficient is not 1, and this will never change. This is always the sum of the numbers we are looking for. So, can I find 2 numbers whose product is -2 and whose sum is 1? Yes, it's 2 and -1. The sum is 1, the product is -2. Good. Now, all I have to do is replace the middle term using the numbers I got. So 2y squared plus 2y minus 1 equals 0. Do not go back and combine like terms. That will defeat the purpose, right? Of what we just did. So here's what I do. I'm looking at the first two terms and I see that I can factor out 2y. So I have y plus 1. Look what I do next. I write in parentheses y plus 1. I write 0 on the other side so I don't forget. And only now I look. I need a sign and a factor. Exactly. And now the common factor is, its common factor is y plus 1, and in parentheses, indeed, 2y minus 1 equals 0. So we have two options, obviously, for sine x, because that's y. That's what y stands for. So the first option, so you made a mistake on the quadratic formula somehow. That's fine. Okay, as long as we know that. And so then sine x equals, what are the options?
Sine x equals 1/2 and -1.
Very good. So now we know what to do. We will have for sine 1/2, oh, -1, of course. You said -1, okay. So for -1, we only have one solution, but for 1/2, we have two different solutions. In which quadrants will I find sine to be positive? Very good. So then I have sine x equals 1/2 plus and plus. And now I'm asking myself, what would be the reference angle? Sine of blah equals 1/2. Exactly, it's the first angle. Very good. So then I have a pi over 6 here. And then I draw a horizontal line this time. And I find in the second quadrant an angle with the same reference angle of pi over 6 that starts, of course, it's a standard angle, starts, of course, on the x-axis. So, yes. In other words, pi minus pi over 6. Pi over 6 shy of pi. So then x has two options, and they are, one more time, pi over 6 plus 2 pi k. And the other one, indeed, 5 pi over 6 plus 2 pi k. I always have to identify what k represents. And I have one more equation to solve. Where is sine -1? Exactly. Right there at the bottom. It's not in the little chart. So it has to be at a corner point. Good. So then from here I have only one solution, x equals exactly plus 2 pi k. Perfect. Awesome. Okay, so now where are we? Cosine 15 degrees. We want to find cosine 15 degrees and then this problem. So 51 cosine 15. Using a formula that we know, an identity that we know. So how do I start?
So cosine of 15 equals cosine of 45 minus 30.
Excellent.
And then cosine 45 cosine 30 plus sine 45 sine 30. And then cosine of 45 equals square root 2 over 2, cosine of 30 is square root 3 over 2, and sine of 45, yeah, 1/2, and then 1/2.
And remember what I showed you, always to factor out. Okay, good. Last problem that we chose before we look at that test, cosine of sine inverse x plus cosine inverse y. So let's work on this. And I want to choose more examples.
So where's the sign come into play?
That one,
Yeah.
the formula for
Cosine alpha minus beta is cosine alpha, cosine beta plus sine alpha, sine beta.
Okay, that's right. So,
I want to go back to something. I'm looking through chapters. So identities, I think we got them. It's just that we have to practice, right? Please practice as much as you can. So then lowering powers, I think we got it. This type of problem, I think we got it. Using a half angle or sum of angles to find the simplified, I think we got it. I have one more type of problem that I would like to look at after we finish this one. This is from the review, and it's problem 70. So I would like to look at one more type of problem, and then I would still like to, for half an hour, to go back to chapter 4, just in case. Are we okay with that?
So we changing the sine inverse of x just to into a regular angle.
You mean sine inverse?
Yeah.
You have to.
Okay.
Because see, this is what this is. It's cosine alpha plus beta. And if you don't work on these and start here, you will not know what this is requiring.
Okay.
Okay, I sent an email to the help desk and the IT to recover those. See if I can. I couldn't recover the deleted items, the emails. So maybe I can find it. Okay, how do we start? We start with sine inverse x being alpha. And we know it's an angle because it's sine inverse is applied to numbers. Sine is applied to angles. Okay, so we do what to this?
So it's going to be plus sine plus
So sine alpha equals x. So there is a right triangle with an acute angle alpha, x over 1, x over 1, the square root of 1 minus x squared. In the same way, I have cosine inverse y equals beta. It cannot be the same angle. So then I know cosine beta equals y. So there is another right triangle with y over 1, which is 1 minus y squared. So therefore, this whole thing is nothing else but cosine alpha plus beta. So when I continue it, I have to write cosine alpha, cosine beta minus sine alpha, sine beta. Is this clear? And now I have to put all the pieces together. I have them. They're right here in front of me, but I just have to put them in this formula. So, how much is cosine alpha?
1 minus x squared.
Exactly.
Oh, okay.
The square root.
Yeah.
Good. How much is cosine beta?
Square root of 1 minus y.
Careful. Cosine beta is, that's it, minus. Sine alpha, please.
X.
Indeed. Times sine beta, please.
Square root of 1 minus y.
That's it. And no one can do anything to this. I will just arrange it in such a way that I don't have anything following the square roots. So y, the square root of 1 minus x squared, minus x, the square root of 1 minus y squared. Okay, I would like to look on page 515. And I would like you to choose a problem from 3 through 10. We did this, but I would like to refresh your memory. And 37 through 42. 515. You will have a problem like this. So let's choose one from 3 to 10 and one from 37 through 42, and then go back to chapter 4. At the end of chapter 4, there is a review and the chapter 4 test. This is the only type of problem that we haven't discussed. I mean, we haven't reviewed. We have discussed. Okay, ready? So please choose. Number 7. So 515, number 7. It was already, I turned already to chapter 4, sorry. You said 7, right? Okay, sine x equals negative 3 divided by 5, and x in the second quadrant, and this is number 7 on 515. We're asked to find sine twice x, cosine twice x, and tangent twice x. Yes?
It's in the third quadrant.
Oh, I'm sorry. Thank you, thank you. Very good. Yes, of course, it would have been a contradiction. Sine cannot be negative in the second quadrant, of course. Thank you. Very good. So, in order to find sine twice x, I will write the formula to sine x cosine x. Obviously, what I don't have is cosine x, so I have to determine cosine x in the third quadrant. I have the formula that says that cosine x equals plus or minus the square root of 1 minus sine squared x. Of course, if you don't want to use the formula, you can use the triangle. I'm fine with any method. But if you go along with me, then you will say, oh, I know, cosine will be, it cannot be plus or minus in one quadrant. Exactly. So I'll say negative the square root of 1 minus this squared. 9 over 25. 25 over 25 minus 9 over 25 is 16 over 25, which is 4 over 5. With this, I completed sine twice x. I just have to put them in. Any questions on this?
Yeah, so sine of 2x, that's the formula.
Yes.
Oh. So then,
This comes from sine squared plus cosine squared equals 1. That's the first identity we talked about. And then you move one term to the other side and take the square root to find one or the other. Is that okay? Yes? Very good. So now sine twice x is 2. Sine is negative 3/5. Cosine is negative 4/5. And I have, this is 12 times 2, 24. 24 over 25. I also need to determine cosine twice x. Since I'm given sine, I will specifically use the formula with sine and nothing else. 1 minus twice sine squared x. Is this okay? Are you with me? So then this becomes 1 minus twice that squared, which is 9 over 25. Or 1 minus 18 over 25. Or 25 over 25 minus 8 over 25, which is 7 over 25. Finally, tangent twice x. I don't need the formula because I have sine twice x and I have cosine twice x. So the answer would be 24 over 25 over 7 over 25. 24 over 25 over 7 over 25. When I flip, 25's go away. 24 over 7. Now, if you're asked, which quadrant is twice x in? How will you determine that? How much is sine twice x?
24, 25,
How much is cosine twice x?
7, 25,
Where can that ever happen?
and the first one.
Of course. So 2x in the first quadrant since both sine and cosine are positive. Very good. So please choose one from 37 through 42.
So 39.
Very good. So let's look at 39. 39. So in 39, we are given cosecant x equals 3. And we are told x is between 90 degrees and 180 degrees. Which quadrant is that?
2.
Exactly. If we have cosecant, which are the trig function we have right away? What is the formula for cosecant? 1 over sine. So 1 over sine x equals 3, cross multiply, and I will find that sine x equals, not possible. Very good, excellent. So now the question is that we are asked to find sine x over 2. We're asked to find cosine x over 2 and tangent x over 2. This time I need to identify the quadrant for this because I will not know what signs to use. I do have the formula that we cannot forget, plus or minus the square root of, what do I write?
1 plus this one.
It's minus.
Minus, right?
Yes, this one is with minus, and this one is with plus. And this one I don't care, because once I have sine and cosine, I will divide. Perfect. But I need to know what to use. How do I find the quadrant for x over 2? Exactly. I divide both sides by, all three sides by 2. So then 45 degrees less than x over 2 less than 90 degrees. And I know that x over 2 is in the, which means I don't have to worry about signs. So then sine x over 2 equals the square root of 1 minus, I don't have it yet, divided by 2. And then cosine equals the square root of 1 plus, I don't have it yet, divided by 2. I left a space in there. How do I determine that cosine? Yes, that's fine, because you have sine. Awesome. So I have, in a right triangle, I have an angle, acute angle x, whose sine is 1 over 3, 1 over 3, which means that this is 9 minus 1, which we like to write like this. So then how much is cosine x? Because right here I have to have cosine x. This is cosine x and this is cosine x. So how much is 2 the square root of 2 over 3? 2 the square root of 2 over 3. 2 the square root of 2 over 3. I just remembered one of my professors from, I'm not going to say where. I think he retired, I can say, from UMBC. He would never ever solve a problem on the board. He would say, from here, it's too messy. You do it. That was his answer, always. He never, ever, ever, ever. So I thought to myself, what if I say that to myself? No, I can't do that to you. So so let's simplify sine x over 2. No, I can't do that to you. So this is 3 minus 2, the square root of 2 over 3, everything over 2 over 1. And flip. So 3 minus 2, the square root of 2 over 6. And I wouldn't mess with it any further. Everything is the same for cosine, which will be 3 plus 2, the square root of 2 over 6. And again, for tangent, x over 2 will be top over bottom, of course, the square root of 3 minus 2, the square root of 2, 3 plus 2, the square root of 2. We can also use this formula on page that I did not request, you remember, but this is, I would give it to you if it has no any use. So tangent x over 2 is 1 minus cosine over sine. But it's going to be the same thing. It's just going to be a different form of this without a square root on top of it. So you can use that if you want. I'm fine with this. Now I would like to go back to chapter 4 and review a little bit there. Is that okay? Yes? Okay, on page 356. Parker, is this okay?
Yeah, I'll just look at that.
So all I have to do is just under the square root divide this by this, and when I flip, the 6's go away and this stays at the top and this stays at the bottom. Because I need to find tangent, which is sine over cosine. So I'm dividing this square root over this square root, and when I flip inside, the top stays, the bottom stays, but 6's will go away.
Okay.
Yeah.
Okay.
Better?
Yeah, I was thinking that these two.
But please ask. On page 356, I would like to look at an expanding. You tell me what you want. Expanding, condensing, word problem, half-life, log equations, exponential equations. Please choose. And I highly recommend, let's meet here tomorrow at 4 instead of 4:30 in case you have questions. If you can.
Please, just like a long equation.
Yes. Yes. So let's look at a log equation. Let's say part D in 6. 6D, log base 2 of x plus 2 plus log base 2 of x minus 1 equals 2. How do we start?
Use the formula, so
Right, but I have to write x plus 2 greater than 0 and x minus 1 greater than 0. This is greater than negative 2 and this is greater than 1. So the domain is 1 to infinity. If I don't find solutions in the interval 1 to infinity, they will not be acceptable. Remember the domain of a log function. This expression has to be greater than 0, not equal to. So only now I condense the left-hand side. Okay, what do I have on the left? I have log base 2 of,
x plus 2 times x.
excellent. If you get confused, put it in brackets so you see it, it's condensed. And this I know is equivalent to what? We start with the base and we go counterclockwise.
2 squared equals x plus 2.
2 squared, and now I will multiply. So this is x squared plus 2x minus 2. It will save a little bit of time, but you don't have to. I just wanted to multiply it. So this is x squared minus x minus 2 minus 4, which is minus 6. I have to subtract 4 from both sides. And then what do I do with this?
Factor.
So let's factor it. Of course it's quadratic. I'm trying to factor it, yes. What do I get? X minus.
X minus 3.
Yes. Yes. And it appears that this equation has two solutions, and they are
X plus 3. X times 2.
not so fast.
Well, x can't even x.
That's why we stated the domain. So please be careful. If you don't want to state the domain, it's fine, but you must go back and check. It's up to you. Okay, let's look at an exponential. 10 to x plus 3 equals 6 to 2x. 10 to x plus 3 equals 6 to 2x, and that is problem 6C. And then I would like to look at a word problem. Any suggestions on how to approach this problem? I have to. Why? Because 10 and 6 cannot be presented with the same base. If I could present 10 and 6 with the same base, I would not make it more difficult and apply log. But here I have no choice. And the reason why we chose log is because we have a 10 in there. If this is 3 and 6 or 5 and 6, it doesn't matter. Okay, so it's better to apply log. So then x plus 3 times log 10. But how much is log and log of the base? 1. Very good. Equals twice x log 6. And now this is linear in x. But I need x terms on one side. So I will be moving x to this side. So 3 equals twice x log 6 minus x. And we know two key words in math and algebra and calculus, and they are or and or factor. In this case, which one works? Factor. I have to factor. What am I factoring out? So 2 log 6 minus 1 equals 3, and I'm done. There are no restrictions on exponentials ever. They are friendly. They exist for any x value. So finally, x equals what? 3 divided by 2 log 6 minus 1. Yes, you can punch it in if you want. I like to look at problem 9. We only have 5 minutes left, and we'll do whatever we can, and we can finish it up tomorrow if you want. The answers may be in the back, I'm not sure. So let's look at 9. The half-life of Krypton 91 is 10 seconds. Half-life, 10 seconds. At time t equals 0, a heavy canister containing 3 grams of this radioactive gas. At time t equals 0, a heavy canister contains 3 grams of this radioactive gas. Very good. Part A. Find a function that models the amount, A of t or M of t, of Krypton 91 remaining in the canister after t seconds. So this is obviously radioactive decay. The mass function of time equals m0 times e to negative kt. Okay. So what are the unknowns here? T is the independent variable. So for the model to be established, we need to determine K, which is the radioactive decay rate, average rate, and the initial mass. But we do have the initial mass. We are told that the initial mass is, right, so for now I have 3 times e to negative kt. I still have an unknown here. Okay. I do know that the half-life is 10 seconds. What ordered pair will that give us? So I'm given 3 grams. In 10 seconds, I will get in 10 seconds, the amount will be, that's it. This is the ordered pair that we are indirectly given. I'm going to use this ordered pair on the model, but I would like you to dictate the equation that I have to write. What is this? 1.5 equals 3 times to negative k multiplied by, exactly. This is how I put the point in the model. When t is 10, m of t is 1.5. We start with 3 grams. In 10 seconds, we get 1.5. So after 10 seconds, it's the half-life. Half-life.
So 3 divided by 2?
Yes. Yes. So what will I have to do now? I'm trying to find k. That's my only unknown, the only piece that I don't have.
So, use log.
It's not cleaned up for log yet.
So, divide by 3.
Exactly. So this is 1/2 equals e to negative kt. Yes, now it's cleaned up for log. And what will I have to write?
Log, natural log.
Of 0.5 on this side equals negative 10k. So k equals natural log 0.5 over negative 10. I plug it in the graphing calculator. So natural log 0.5 divided by, in parentheses, negative 10. And that will be the radioactive decay rate. And now I have the entire model. Can anyone dictate this model? M of t equals? Yes? Yes?
Negative 0.0.
4 digits we need. Yes. Times t. Excellent. This is the model. This is what we're asked in part A. Part B. How much of this radioactive substance remains after 1 minute? The time is in seconds. Yes, so I have to find m of 60. 3e to negative 0.0693 times 60, and everyone can do that. Part C. When will the amount remaining be reduced to 10 to negative 6 grams? So the mass, 10 to negative 6 grams. When? How long it takes for 3 grams to become 10 to negative 6 grams? And what do I have to write?
2 negative 6 equals
Exactly. So this is part B, this is part A, and this is part C. 10 to negative 6 equals 3e to negative 0.0693 t. I have to clean it up. So 10, you don't have to mess with that at all. So just apply natural log and then divide by that number. Let's see how many seconds are required for this. I know I held you 1 minute over, I'm so sorry. But if you want, I can stop. So natural log of 10 to negative 6.1, 2, 3, 4, 5, 6. Oh, no, I'm sorry, 1. I didn't mean to write 6. 1. So 2, 4, 6. I have 6. Good. Divided by 3. Close the parenthesis and divide everything by negative the previous answer. Okay. So I got 215 seconds roughly, 0.2. So t approximately 215.2 seconds. Thank you very much. Please review what we did. Please come in early if you can.